Cell MS3, I've got the TCS cell out, and be advised those ball foot clamps were down with an incredible amount of torque, clearly more than was needed.
Dave, let me verify. You said you had to use more torque than you thought was needed for the ball foot clamps?
Yeah, it was, first I thought I had gotten something unlocked, but I finally had, I didn't take an additional tool, but I really had to apply an excessive amount of force to get them off.
Okay.
My hands are good and raw right now.
Oh, we're sorry to hear that.
Council, this is Spacelab.
Go ahead, Spacelab.
Okay, on the beam adjustment, I have the video selected for FPS, and I have a very homogeneous screen now. But of course, we haven't anything in the beam, so there's nothing to see. But at least I have a homogeneous illumination, and therefore I don't think that it's a big need to readjust the wait a minute, screws 1, 4, and on the beam adjustment. So it's called the mirror mount, I think.
Yeah, we concur in that, Ulf. Good call.
Right now the knife is rotating, but there's so far nothing that obstructs the beam.
Copy that. Is that the 271 data ident?
That was a data ident 271.
Copy that, okay.
And Huntsville MS3, I'm looking at the crystal lights in the cell right now, and they all appear to be prismatic in shape. No appearance of the needle-like nickel.
Sorry, we have voice again.
And just for your information, Dave, we were doing a TDRS handover, and we lost it right after you said that there were none of the needle-like crystals in there, so we lost the rest of that description.
Okay, I just wanted you to pass along to Robbie that it looks like they're all the crystal lights are prismatic, and none of the nickel impurities that he was asking us to look out for, the fine needle shaped type impurity, so it looks good.
Yeah, we got that, and he's nodding. He's real pleased.
Council, this is PS2.
Go ahead, Ulf.
Okay, we took 2 snapshots to verify the magazines. Dave thinks that there is vacuum, and I haven't seen it, but another concern is really the transfer mechanism. The take-up adjustable starts to rotate, it turns around about quarter of a turn, and then it goes backward again.
Copy that. The take-up spool starts to rotate, then goes backwards.
Yeah, it is as if it loads a spring, and as soon as the force or the torque is released, the spring pulls it backward.
Okay, we copy. Can you look at the front, Ulf, and see if the film's moving or not?
We'll take another one, and I use a pan and put on the film to see where it's moving.
That'd be a good move, yep.
And we'll look at the 312 readout and just see what it's doing at each step and give you a call on that.
Yeah, we copy that, Dave.
Okay, it looks like it moved an inch at step 12. The take-up reel rotated clockwise and then back counterclockwise. The film moves about an inch or a little more than an inch, maybe 3 centimeters.
But definitely not a full frame.
Is that satisfactory?
Could you try it again with the transverse camera and do the dot and see how far it moves again? We need for it to move a full frame, I think.
What should you talk to us?
Yeah, what I was saying, Ulf, is that do it again with the transverse magazine, and I think we need for it to move a full frame.
Okay, we'll do that.
Am I breaking up when I come on, or just not very clear?
No, you're coming on. Which command do we use for the transverse here?
Stand by, Dave. Yeah, the 306 will move both pieces, both magazines, Dave, so just enter the same command. Swatch the other magazine.
Okay. Oh, I got you. Okay. Okay, we got a 301 host not loaded error message when we did that. We could clear it and try again.
Say again on the error, Dave.
It was a 301 error. And that's host not loaded. We cleared it. We're going to try 306 again. Okay, it worked this time. It must have been a transient. And we're looking at the transverse. What's up? This is PS2.
Go ahead, Ulf.
Okay, on the film magazine number 2, the transverse magazine, the shutter opened, there was vacuum. I put a little mark on the film, but the film didn't move.
Okay, what we'd like for you to do is on the primary camera, rotate the take-up spool and see if the film moves.
You said rotate the take-up spool, and what is the rest?
And see if the dot moves across the screen, across the open area.
I rotate the spool manually. I advance the dot by about 2 centimeters.
Can you get it to go all the way across?
I moved the film, let's say 2 centimeters, by rotating about 90 degrees on the take-up spool.
Okay, continue to rotate the take-up spool and see if the dot moves entirely across the field.
That's affirmative. It does. It does move.
Okay, and try that on the transverse also, please.
That that's the one he just moved. He wants to try it on the vertical one?
The primary. That's affirmative,
Okay,
Dave,
we just did it on the we just did it on the transverse. If it's okay, we'll try it on the primary.
Copy that.
Spacelab Huntsville for Dave.
Go ahead.
Dave, I wanted to verify that the test cell is still out. It's not in stowage and it's not in the optical bench.
That's affirmative, and that's why I'm not going off and doing something else, because there's I really can't stow it anyway without possibly letting it fly loose, so I'm just holding on to it.
Yes, we understand that. That's one of the rapid saving items. We've checked with Ravi, and seems okay. If we could go ahead and put that in optical bench, we could free you up to do this G-Thrush and Photran that are coming up. It's about time to be doing those right now.
Okay, we'll put it in the optical bench.
Thank you.
Okay, Huntsville, we've got the test cell installed.
We copy, Dave. Test cell installed.
Okay, do you want me to pick up that BCGS mod now, or go on to G-Thrush?
Please go on to the G-Thrush.
Okay. Console, this is PS2.
Bill.
Okay, Roger, we have the cell installed, but it remains still doubtful whether the film advances properly. We did 3 or 4 snapshots, and I'm not positive whether the film really moves the way it does. On magazine 1, we put a dot on and tried again, and it moved a little bit, and then it came back.
And when you rotated the take-up knob, did it move manually?
Yes, it does.
Okay, it sounds like that lock and key in the bottom is just not engaged often. I don't know what to do about it right now, so stand by. Okay, well, what we'd like to do is to find out whether the key's turning at all or not. So if you take the magazine off of the primary and do a snapshot and just observe whether the take-up spool key turns or not.
Okay, we'll do that.
Thank you.
Okay, Roger, I put my finger on the key, it rotates.
Okay, what we'd like for you to do now, we copied that it rotates. What we'd like for you to do is manually turn the take-up spool while looking at the bottom of the magazine and see if it turns. See if the take-up turns on the bottom part.
Okay, you want me I have the magazine still out. To rotate on the take-up spool and observe what?
Look at the bottom of the magazine, and there'll be a slot in the spindle that goes through the film, and just see if that's turning for sure. I mean, I think it will. But
Hey, Roger, folks having a little trouble when we're understand you when we're right next to the optical bench there with all that noise. It's hard to understand, so could you try that again?
Yeah, all we're looking for, Dave, is that what we see now is that the key on the drive is turning. And it should engage in a slot in the bottom of the magazine on the take-up spool side. And when we rotate the top manually, we just want to see if the slot in the bottom is also turning. apparently there's not a through rod. It's not a one-to-one connection.
Okay, I guess you're talking about the drive mechanism that locks on the key on the other side. Is that correct?
That's correct. The drive mechanism that's in the magazine. See if it turns.
Okay, if I rotate on the take-up side, that key turns on the magazine.
Okay, thank you.
Okay, I'm reinstalling the magazine then.
That's a good call. Keep going. And when you finish getting it, when you get that back on, though, we'd like for you just to go ahead and proceed with the heat up, and then we'll try to figure out what's going on down here and let you know over the next 6 hours or so what we're going to do.
Okay, Roach, this time I've reinstalled the magazine and I've turned the take-up spool in the arrow direction, and now I'm hitting a hard stop. It doesn't go any further.
Good news. All right. And that's on the primary camera?
That's the primary. Let me do the same thing also on the secondary, on the magazine number 2.
Okay. Only if you promise to do it right.
Spacelab Huntsville for Dave.
Go ahead.
Yes, Dave, the GPPFTI would like for you to call down the STEM times when you put them in, and I believe that's in part of the procedure, step 3.15. You have a prompt, enter STEM time. In addition,
Okay, I'm
step
just about
3.
to get there.
Okay, and in addition, step 3.12.
Okay, you say you've got a change to in step 13?
They said they don't have a change. They just want to know what you put in.
Okay, unless they tell me otherwise, I'll put what's in the procedure there. Looking at the cubes there, the plants were generally vertical, but a couple exceptions to that, and most of them were approximately 3/4 of the way up the cube in height. And were you saying something?
I was just trying to clarify that even though it's not a change, they still want you to do the GPPF MET plus 1 hour. They still want that called down.
Oh, okay.
They're trying to say they want to know what time that is done.
Okay, that makes sense. I'll go to it in a second. Okay, I'm entering for the STEM time, 1 day, 14 hours, 43 minutes.
Discovery Houston, about 30 seconds from LOS, back at 13:55.
As you guys are going over the hill, Ulf, we'd like for you to proceed with the FES and do the startup.
Okay. Copy.
This is Spacelab Mission Operations in Huntsville. Our next Spacelab TV event Coming up will be the vapor crystal growth system with live downlink from the Shuttle Discovery. That's due to occur at mission elapsed time of 1 day, 13 hours and 54 minutes. It's currently 1 day, 13 hours and 45 minutes, so it'll be just in a very few moments, or at 10:47 p.m. Central Standard Time. We are on LOS at the present time, meaning that we have lost our signal or our communication with the Shuttle Discovery as it's moved out of range of the TDRS West K-band tracking satellite, but that communication will be restored in about 7.5 minutes. In the meantime, we've just received an update from the Microgravity Vestibular Investigation Team. They're continuing to work the problem, the short circuit problem with or the fuse problem with their mobile chair. Expect to make some progress on that within the short time span, within the next several hours. That problem is being worked interactively between the crew on board the Shuttle Discovery, the science team here in the Science Operations Area at Spacelab Mission Operations, Marshall Space Flight Center, and the controllers and technicians here at our Spacelab Payload Operations Control Center. One of the highlights of these shuttle missions always is the partnership that occurs both in orbit and on the ground as the engineers and the scientists put their heads together to try to come up with workarounds when problems arise. Sometimes equipment performs differently in space, in the zero gravity environment, just like our bodies do. One of the purposes of this particular mission, the first International Microgravity Laboratory mission, is to determine how living beings and materials perform in space. Sometimes we learn some things about equipment that has never flown before. Thus far, the technicians and engineers believe that the MVI chair is a bit more sensitive than it was in regular gravity, and that may be the problem that they're encountering on orbit in the microgravity environment. At any rate, as we indicated, that problem is being worked. And in the meantime, the crystal growth experiments that have been activated in the last few hours are continuing and are being worked. At the present time, the crew in the Spacelab module are setting up the triglycine sulfate crystal growth experiment. This is an experiment that has been provided by NASA under the supervision of Principal Investigator Dr. Ravi Lai, who is from Alabama A&M University here in Huntsville, Alabama. Triglycine sulfate crystals have the technological potential to serve as infrared detectors that can be used at room temperature with small cooling devices. Many applications for improved infrared detectors in military systems, in astronomical telescopes, in Earth observation cameras, and in environmental analysis monitors. However, unfortunately, when these crystals are grown on Earth, they develop defects that limit their performance. In a microgravity environment where we do not have problems of sedimentation and convection and buoyancy, the crystals grow much more uniformly and are much larger. Triglycine sulfate solution is transparent, so it's possible to record holographic images of fluid motion around the growing crystal, and that's what payload specialist Wolf Mirbold has been working on in the last period to set up the cameras and to arrange that experiment so that those pictures can be taken. Two types of images are made. Sclerin images, which are transmitted during the mission as black and white video that we will be receiving. This shows variations in fluid density and flow patterns. And the holograms, that is three-dimensional recordings, that will be reconstructed here on the ground and analyzed after the mission is over. Holograms and video data are recorded during mechanical operations and critical phases of crystal growth. During this particular experiment, the principal investigator and his team here at the Marshall Center monitor the downlink video of the crystal and the growth solution, and from time to time they may have occasion to instruct the crew on board the shuttle to adjust the temperature to induce more uniform crystal growth by changing the growth rate. The vapor crystal growth experiment is also underway, another crystal growth activity. And in the meantime, the life sciences experiments, which were begun yesterday during the first day following the launch of the Shuttle Discovery, those activities are continuing. They include a number of biorack experiments provided by the European Space Agency, including the fly eggs experiment and the cell culture experiment, as well as a number of plant growth experiments that have been also provided by some of our international partners in cooperation with NASA. The IML mission is the first International Microgravity Laboratory experiment, the first of a planned series of 4 such missions to be conducted during this decade. It involves 14 countries and over 220 scientists who have gathered here at the Marshall Center, as well as at the Kennedy Space Center in Florida, to watch and to monitor these activities. This is an exciting period for these scientists, many of whom have spent over a decade in the planning and development stages. Some of the experiments have flown on previous shuttle missions, such as Spacelab D1 back in 1985, which was in partnership with the Germans, and the first Spacelab mission back in 1983. The nations involved in this mission include the United States, the European Space Agency, the Canadian Space Agency, the French National Center for Space Studies, the German Space Agency, and the National Space Development Agency of Japan. On this mission, our 2 payload specialists are representatives of those nations. Payload specialist Roberta Bondar is from the Canadian Space Agency. Payload specialist Irv Mirabal represents the European Space Agency. Again, we're working 2 sides of the street, so to speak, on this particular mission, both life sciences and materials science. The 2 are complementary because as the life science experiments require a lot of crew interaction and involvement, don't consume much power, the material science experiments do not require as much crew interaction. A number of them are activated and operate themselves with some monitoring, but they consume a considerable amount of power, relatively speaking, and so they're somewhat compatible. In just a few seconds, we'll be reacquiring signal at mission elapsed time of 1 day, 13 hours and 53 minutes. This is Spacelab mission operations in Huntsville.
Spacelab Huntsville, we are go for voice.
Roger, Huntsville, okay.
This is Spacelab mission operations in Huntsville. We're receiving new live downlink video from the Spacelab module, and in particular at this moment, video from the vapor crystal growth experiment system.
Dave.
This experiment is under the direction of Dr. Ludwig Vandenberg. It attempts to grow a large mercury iodide crystal in the microgravity environment of space. Dr. Vandenberg is supervising the activities here in the Science Operations Area
Go ahead, Ulf.
at the Marshall Space Flight Center. He himself has flown as a payload specialist on earlier missions. In fact, he was the payload specialist for the Spacelab 3 mission, which flew this experiment before. He's seeking now to build upon the data that was gathered at that particular time.
Okay, I copy.
And to further his research, along with his colleagues.
Okay, I'm taking the
This particular experiment is provided by NASA and has two purposes.
All the way down the page, I got
the first is the growth of crystals in a microgravity environment.
542,001.
Of course, gravity interferes with the movement and the transport of materials from the source of the crystal growth to the growing crystal. That's due to convection and changes in gravity due to heating.
That's
However,
affirmative.
in space, it's easier to analyze the critical factors that determine the quality of the crystal
It
to
is
be
some
grown
sort of
and
a
the process of
temperature
growth itself.
violation, and
The second purpose of this particular experiment is a technological understanding aspect. Crystals are being developed for use
Okay, I copy.
in this
Stand by.
instrument that measure radiation. These crystals are believed to be good for environmental monitoring, such as for monitoring radon, nuclear plants, hospital leaks, and so forth. They're also used in astronomy and astrophysics. We need to grow the highest quality possible crystals. It's important for the crew to have visual observation of growing crystals,
Yes,
as it
the
is
PI
for the
said to
science
just continue.
team here on the ground. That's why the
Just continue
live
from where you
video
are
is
now.
being provided to them so that they can
Okay,
make suggestions
starting step
for
7.
adjustments to the heat and the other conditions for those growing
Copy.
crystals. During the mission, the crew will be cutting slices from the space-grown crystal and looking at that.
So would you like the
once
stimulation
it's
values
returned to the
for
ground,
step 7 to
crystals will be analyzed further. Such crystals can be used in devices to compare with quality of Earth-grown crystals.
The PI
As
tells me
Dr.
they have that data,
Bondar said
Dave.
in a recent briefing, says you learn in space how to do it right, and then you repeat it here on the ground. That mission elapsed time of 1 day, 13 hours, and 59 minutes. This is Spacelab Mission Operations announcement.
Substep 1, safing relay light on.
Okay, I hear the noise of the water pump. And I have a new area. The error code is 542,001, as before.
Copy. Go ahead. And Ulf, they tell me that's not a problem. You're getting delta temp violations on the water, and that is coming down now.
Council, are you still there?
Yes. They said that those that error code is not a problem. Those are delta temp violations, and that is going down now.
Okay. I pressed the safing relay reset button once. The light did not go off. I'll wait another minute and I will try again.
Copy.
Okay, I pressed the safing relay button once again. The light show is still open.
Copy, Ulf.
And they want me to go on with substep 2.
Yes, Ulf, go ahead and make those changes to that timeline, and then try the safing relay.
Okay. We are using timeline number 1.
That's affirmative, Ulf, and I don't know if you have these changes. I don't know if Roger voiced them up. I don't think he has. I think he's
Not
going to
yet.
in just a minute.
yet. I'll let you know as soon as I'm there. Okay, go ahead with the changes now.
Okay, on NOM 33, in table 3.1.
Okay, I'm there.
ID number 525. The update will be plus 001811. There's only two of them. I'll give you the other one. The other one is 526, and the update is plus all balls 1.
Okay.
That's it.
Okay, let me read it back. On data item 526, that is all balls 1 and 525001811.
That's a good copy.
Okay, update is complete.
Okay, copy that.
Okay, I entered data item 544, and the readout shows all balls in the 5. That completes step 7, but be informed that the shaping relay light is still on. You want me to press again?
We'd like for you to do that.
That's still on this 3. And no joy, Roger. It's still on. The light is still on.
Copy, no joy.
That's still on this 3.
Go ahead.
Okay, I'm finishing up step 7 in PhoTran, and when I tried to hit the photo stem button, there wasn't any response. Expected prompt for the inner stem episode. I think I remember this was a note to us, something about we have to hit G-pulse left to cancel it. Is that correct?
That's a negative, Dave. Can you stand by just a second?
Okay, what's happening is when we hit the photo stem, we still get the all we get was the stimulation values up there. Okay, so I'm starting VC chairs at 1, steps 4 and 5.
Before you do that, Ulf, what's the status on the transverse film magazine? When you put that back in, did it also lock down?
Negative. I tried at least half a dozen times. I moved it, put it on, and turned it, and somehow I understand now the mechanism. On the magazine, the little key is spring-loaded, but it has to snap into the hard-mounted key on the dry side within a fraction of a degree, and if it doesn't snap on, if it doesn't snap at that point in time, then you turn another rev, and obviously that's a problem.
Yeah, I understand that. And when you looked at it, there weren't any burrs on either side of the key or anything like that, right?
No, it's all clean and fine. But maybe if the mechanism starts to move, maybe then it snaps in. I don't know.
Yeah, I understand. Can you stand by for just a second? Ann wants to talk to Dave, and then I'll come back to you.
Okay.
And,
go ahead, Ed.
Dave, PI said to try / enable, that possibly they were in a data collection mode, and if you try that, it may re-enable the keypad.
Okay.
Okay, Ulf, go ahead and do the CTS mon then.
Okay, we'll do that. Yeah, that seemed to work.
That's great.
Here did the rest view. We've got 4 views of the plants, and they look pretty uniformly straight, and I'd say the average height is about 2/3 of the distance of the height of the cube.
We copy.
And for a systems check, we've got left and right test rotors are at 0. Stand by. Okay, we got 61.6 and 60.6 for the left and right culture rotor, 22.3 for the test rotor temp, and 22.6 for the culture rotor temp. Now we keep getting the video and expressions first here, and 22.7 for the rest temperature. And that completes step 7 of 2.1.
That's great. We copy. Thank you. Dave, could we get confirmation of slide removal?
That's affirmed. Slides are all removed.
Thank you, Dave.
Okay, Ansel, this is... Say again, Ed?
Yeah, Dave, we're running into your lunch a little bit. I'm not sure, but we still need that tape change on GPPF.
Okay, I'll get the scheduled activities done before lunch.
Thank you.
Yeah, Ansel, this is PS2. I took a look at the crystal. It looks real nice, except there is this one piece of dust. Meanwhile, I have also a video image on the FES video monitor, and I'm not sure whether you have the same picture, but it's also visible on the video. And I'm going now to daylight at 730.
That's affirmed. We do have a copy of the video down here, and it looks good. I think we can see that it's on the face that's directly facing us now. Is that correct?
That's a term. It's like a little hair or something like that.
Yeah.
Okay, Roger, on daylight at 730, is there anything for me to enter as a data select?
Stand by a minute, Ulf.
I understand no, negative.
Stand by a second, Ulf. That's an affirm, Ulf. It is a negative response. We don't want anything entered yet.
Okay, in this case I go to daylight at 7:04. On daylight at 7:04, the readout is all volts and a 0. And that means notify the POCC.
Copy that.
Any action?
Stand by one.
And Spacelab Huntsville for Dave. Just wanted a reminder that we need a lunch status before you leave for lunch.
Okay.
And we just wanted to know what the values were on 704. It looks like it's heating up nicely, and the PI is very pleased with it.
Okay, so on the data readout, all balls 2, on data ident 704, no action required.
That's a good copy.
And
Okay, yeah, I'm sorry,
okay, Roger, go ahead.
I was listening to the PI, and I'm sorry I was gone so long. What we'd like for you to do is to go off to lunch now, make certain that you're back by 15:10, and we'd like to get a status report before you go to lunch. And also, when you get back, just be aware that the VCGS PI wanted us to tell you that there will not be the downlink, any downlink data on the VCGS.
Okay, copy that. And on data ident 747, also no action for the time being.
Stand by. .747 should be all zeros.
That is correct. It is exactly what it does. And I tried again the safing relay light. It didn't work, and because of that, I checked the FPS circuit breakers. And sure enough, on the safing, it's on the box it just says safing, but I think that is the safing relay light. There is one circuit breaker popped, and that is called reset.
That when you looked on the circuit breaker panel, one of the circuit breakers marked reset was popped.
Okay, there are two circuit breakers. They have the heading safing, and then each of the two has a sub-label, and one is labeled reset, and the other one is labeled light. And the circuit breaker with the heading safing, subheading reset, is popped.
Okay, we copy that. That sounds like an interesting find, and we'll be working that while you're off at lunch.
Okay.
Thanks, Lil. And we still need that status report. When you and Dave want to get send it
we'll
down.
do that.
This is Spacelab Mission Operations in Huntsville. Once again, we've received just a very few seconds of downlink video from the gravitational plant physiology experiment on board the Shuttle Discovery and the Spacelab module. These few seconds are really all that the science crew here on the ground need to see. To confirm that the plants are indeed growing, and how much they've grown, and in which direction they've grown. The major purposes of this particular experiment is to see.
That's still MS3.
Go ahead.
Okay, I'm done with the G-flash tape change, and both Wolf and I feel like we'd be ready for additional activities this afternoon.
Okay, I copy that, and just want to give you a quick heads up before you begin fly. When you come back, I have a procedure to call up to you.
G-thrust, it was just mentioned.
Okay, you want to give it to me now or later?
I can just give it to you later. That's okay.
Okay.
G-thrust, it was just mentioned, stands for gravity threshold. It's the gravity stimulation of plants experiment, part of the gravitational plant physiology facility. The science team is seeking to determine how plants grow in space, because on extended space missions, one of the plans is to take plants along to provide oxygen in exchange for carbon dioxide and to provide food, just like plants function here on Earth. And the experiment is meant to investigate the changes that occur when plants are exposed to different levels and durations of gravity. So some of these plant samples are placed in a centrifuge where gravity, as we have here on Earth, is simulated in various degrees. And we also have those plants in a near zero gravity environment. The experiment uses a centrifuge to determine the sensitivity and threshold of the gravity detecting mechanism of oat plants. These oat plants were used because we have considerable experience with growing oat plants and experimentation here on Earth, as well as in space. And also because they develop quickly and have been used in more studies of gravitropism than any other plant. The gravity threshold experiment also studies how a growing plant responds to altered gravitational fields and how microgravity affects a plant's structure. Until this particular mission, investigations of this kind were made only on Earth, where the results were distorted by gravity. Another portion of the gravitational plant physiology experiment is nicknamed PHOTRAN. It's an experiment meant to gauge the response to light stimulation and allows the scientists to separate the response to light from the response to gravity. Here on Earth, the two phenomena mask each other, but in space they can be separated, so scientists can learn more about why a plant is behaving the way it behaves. Different groups of seedlings receive different durations of light exposure, and the seedlings' responses are monitored by infrared sensitive time-lapsed video cameras and recorded for analysis. Some of these samples on board the Shuttle Discovery will be fixed chemically so that their growth at a particular point in time can be frozen and then studied here on Earth, and others will be allowed to continue to grow. At mission elapsed time of 1 day, 14 hours and 24 minutes, this is Spacelab mission operations in Huntsville. This is Spacelab mission operations in Huntsville. Live downlink video is now being received here in the Science Operations Area and the Payload Operations Control Center from the Shuttle Discovery. This particular broadcast was unscheduled on the timeline, but it's one of those special opportunities that arises during a mission like this when unexpected phenomena occur. The scientists here want the opportunity to be able to to look at it. That video is of the critical point facility in the Spacelab module. The scientists watching with considerable interest here are members of the CPF team from the European Space Agency. They're seeing considerably different pictures from the critical point facility than were being observed at this particular hour at this time yesterday, when we received quite a bit of downlink video from that particular experiment. Critical point facility is electronically coupled to the ground, meaning that scientists have an opportunity to participate in something relatively new called telescience. The CPF facility is a bit unique in that respect as far as the current IML experiments are concerned. Telescience allows the scientist to interact with the crew on board and to get science in real time. The CPF team does not, like many of the other scientists, have to wait until the mission is concluded to analyze their data. They see it in real time and can react to it and tell the crew to make adjustments to the temperature and other environmental conditions in that particular experiment facility, so they can enhance the progress of the experiment. Critical point is a specific point reached by a fluid when it's heated and when the pressure is increased. At the critical point, liquid and gases are the same. The control of fluids, one of the more complex problems of living in space. That particular video opportunity is now past, and we return to our regular video timeline, again receiving live downlink pictures of the vapor crystal growth experiment. One of the other materials processing activities being conducted during this 7-day mission. There are several crystal growth experiments during IML. All aimed at producing different kinds of results. Some are intended to grow actual crystals in space, where we don't have the problem with sedimentation that exists in gravity here on the Earth, and where therefore we can grow better, larger, more perfect crystals that can be used in all kinds of electronic hardware here on Earth and for various and sundry purposes. The vapor crystal growth experiment uses large mercury iodide crystals. They can provide exceptional electronic properties. Beyond that, they also operate at room temperature, so you're not burdened by bulky cooling devices that other crystals require. And they can be therefore used in portable detector devices for nuclear power plant monitoring, for natural resource prospecting, for biomedical applications, and the diagnosis and therapy of disease, as well as for astronomical observing. Here on Earth, however, we cannot grow perfect crystals, and there are a lot of defects. And so there are high hopes that crystal growth manufacturing may develop during longer-term space exploration, longer man-term presence in space, so that these kinds of devices can be developed in a more systematic way and grown for use in remote detection, electronics, and medicine, all of those purposes. On IML-1, there will be considerable interaction between the crew on board the shuttle and the principal investigators and their support teams here in our science operations area at the Marshall Space Flight Center. Because of images like this, where the scientists on the ground have a chance to react to what they're seeing and can tell the crew on board to make adjustments in the experiment, excuse me. This allows the process to be tracked through each and every stage, and scientists can change any of a number of parameters to adjust the growth and to reduce defects, one of which they were talking about a few moments ago. They perceived what appeared to be a defect on the face of the crystal that is now being viewed in the live downlink video. Vapor crystal growth experiment has been provided by NASA and is being supervised by Principal Investigator Dr. Ludwig Vandenberg. Dr. Vandenberg flew on the very first Spacelab mission as a payload specialist. Mission elapsed time of 1 day, 14 hours and 38 minutes. This is Spacelab mission operations in Huntsville. Spacelab mission operations in Huntsville. Among the individuals, among the over 220 scientists who have come here to Spacelab mission operations at the Marshall Space Flight Center to participate in this mission are several representatives from the VCGS, or Vapor Crystal Growth Systems Experiment, monitoring that particular experiment and the crystal being grown on board the Shuttle Discovery at this particular time are Kevin Kasahong, who is an engineer, Richard Sharp, and John Sunderall, all members of the VCGS team. As is the case with many of the experiments, this one has been in development for quite some time. The scientists and engineers and technicians have put a considerable amount of effort and energy into developing experiment systems that will take advantage of the microgravity environment in space. Dr. Ludwig Vandenberg of EG&G Incorporated in California is the principal investigator on the Vapor Crystal Growth System experiment, most especially the vapor crystal growth study of singular mercury iodide crystals. He served as a payload specialist on Spacelab 3, on orbit as his colleague Wolf Meerbold is now. And because of the considerable understanding he developed during that mission and his years of working with crystals, is directing this experiment from the ground during the IML mission. During the next several hours, work will continue on the crystal activities, which were some of the later experiments turned on during the IML mission, which began early on the 22nd of January. It's now nearing the conclusion of its first full day in space, its second day in space. Scientists are also working on the fluid experiment system. It and VCGS were turned on today in the wake of a number of other experiments which were activated yesterday. There's a very complicated timeline that the crew on board the shuttle and the ground controllers here in Huntsville and at the Johnson Center in Houston have to observe. This is one of the busiest Spacelab missions to date, with over 40 experiments that range from life sciences through material science. And it's very important that the crew stay on the timeline to maximize the scientific results and opportunities. And sometimes, as was the case a few moments ago, there are unexpected opportunities when scientific activities occur. And this mission is built with some flexibility to allow the crew and the science team here to take advantage of those unexpected opportunities to receive live downlink video and voice communications and data communication that will enhance the science. IML-1 is a 7-day mission, and it's a preparatory mission in part for the U.S. Microgravity Laboratory mission scheduled to launch in June of this year. That will be a 13-day mission. Mission elapsed time of 1 day, 14 hours and 51 minutes. This is Spacelab mission operations in Huntsville.
fill in this 3-spec and ready to copy those deltas on the fly.
Okay, Dave, really need to get ready because I have 4 flight notes to read up to you. The first one, I'll start with the fly thing, and if you'd like, I'll just read through the procedure once so you'll know what I'm talking about, and then if you want to take it down verbatim, we can go through it again. Is that okay?
Is this the same thing as the tags message that came up this morning?
No,
About deleting the mail.
No, that's some procedure changes, and I have those, but I'm not calling them up. This is a procedure to use a plastic bag when doing the rest of the fly procedures.
Okay.
Okay, here goes. As a precaution to prevent uncontrolled fly escape, open container fly 1, 2, 3, and 4 separately in a plastic bag. If there are flies escaping into the bag, close container, kill all flies in the bag, and stow the container in compartment L inside the glove box. They're saying to consider it as a leaky container. If no fly is escaping inside the bag, take the container out of the bag and continue with nominal procedure. And the location of the plastic bags, there are 2 in compartment Romeo of the glove box, or there are some in Spacelab.
Okay. You want me to do this to try to open fly trays 1 through 4 in a plastic bag, and if there are some in there, then we'll go ahead and close up the tray and kill the flies and stow the plastic bag in compartment Lima. I guess let me take a look at the bags that you're talking about in a second, and let me see if I think it will work or not.
Okay, I will stand by.
And Dave, this is APS. Just be advised that they're looking at the Type 2 bags, the bags you put a Type 2 container in.
Yeah, the problem, I've got one of those bags out. The problem seems like would be getting both your hands in there and being able to close it. If the fly really did escape, you'd have to have the thing completely inside the bag and available to seal it right away. We can give it a try. I have no problem about that, but I'm not sure I can do all of it one-handed because that's all I think I can get. The bag opening is only large enough for one hand, but I'll give it a try.
Okay, what they're thinking about is not necessarily you put it in the bag, seal the bag, and then open it through the bag. Okay?
All right, okay.
And they think the bags are strong enough they won't puncture with that. Then you pull the container, you take the cap off, and pull it part way out. And if you don't see any flies then, the assumption is that that's not the leaky container. So then you can go ahead and open up the bag, take it out, and do a normal food tray change.
Okay.
Does that sound doable?
I'll give it a try.
Okay.
It's a Spacelab mission operations in Huntsville. Just had some air-to-ground conversation between alternate payload specialist Roger Crouch and mission specialist Dave Helmers.
Yes, the next thing is that plus or minus 1 hour from hour 15, we'd like a SAM status check. So just sometime plus or minus from hour 15.
The concern being expressed and the instructions being given involve the
minus an hour 15 from now.
Involve the BioRack fly eggs experiment.
Yeah, that's affirmative.
Okay.
Okay, and the next flight note I have is on BioRack, is to move some things in the timeline. First of all,
Okay.
Okay, I'll
let me
stand
get my
by.
cap.
24 hours ago in the timeline.
I have the P-cap.
Okay.
Go ahead, Ann.
Okay. Sales that was currently scheduled at 16, move that to 1 day, 15 hours, 40 minutes. And the spores, activity 3 should move to 1 day, 16 hours. Come to think of it, David.
Wait a minute, hold it. Where's spores activity 3?
I don't know where spores activity 3 moved from, but they're wanting to add a spores activity 3 at 1 day, 16.
Okay, activity 3 at 1 day 16.
That's affirmative, and that cells that moved up to 1540, that's an activity 4.
Okay, spores will be activity 3 at 16 and cells activity 4 at 1540.
That's affirmative, and I have one more flight note. You'll also need the P-cap. It deals with the sled Okay, I'm sorry. The sled rotation FO2 at 1605. And that's MS3.
Okay, we got it.
Okay, and then the sled rotation FO2 at 1622 on ULF.
Okay.
Okay, and that's all I have right now, Dave.
Instructions being given
Okay, I'll
to
get
the
busy on the fly. Activity 2.
Okay, thank you.
instructions being given to the mission specialist and payload specialist on the Spacelab.
From PS2, is there anything I can do for you?
Yeah, if we'd like for you to do the VCGS, and on the PCAP that I'm looking at, it's the VCGS activity that was originally slated to start at 1354. So that'll be FO1, step 4, in the heat-up phase, and then go into the step 5. And we will not have the critical TV downlink, but we need for you to just sort of work with the PI and tell us any descriptors that we need as we go along.
Okay, Roger, say again where that activity was originally scheduled. I have a pen and ink mark in my PCAP, VCGS Mon FO1 scheduled for 1612. Is that the one you are talking about?
Stand by just a second. I'll be right back. Okay, thanks for standing by, Ulf. But what we'd like for you to do, since we don't have the video until about 1540, and we've got the problem with the TGS or the FES, what we'd like for you to do is sort of give Ludwig a verbal description of what the crystal looks like now and the status of things as you see them in the VCGS. And then we'll troubleshoot, maybe if we get permission to do it, the connectors on the FES. And then at 1540, we'll come back and start doing the VCGS again.
Okay, Raj. The first thing I'd like to report is an error message on the FES. And the readout is 543-001.
543-3001.
Negative. 543-001.
Okay, that's an indication that the heaters are not meeting their set points, and in fact, since they have no power, that's what we expect, so it's okay.
Okay, I have another error. That is error code 545001.
Copy 545001.
That's affirmative, and that is probably also temperature violation.
That's an affirm, and in fact, there's a whole stack of them. As we go through, you're going to see that there's a whole stack.
Okay, you don't want me to read the whole stack out.
That's an affirm, yep. Do not read it out. We don't need them.
Okay, I cleared all the error messages. And now on the VCGS, there are additional crystallites, and it's the yellow modification. There are at least 3 sitting on the base plate of the ampoule. Yellow mercury iodide.
Okay, are these attached to or very near the seed, or are they quite a distance away, say a few millimeters away?
Okay, stand by. I have to rotate to find out how they are located, where they are located.
Okay, Bill, my mistake. Sorry to bother you during the IMAX. Marshall would like for you to set up TV13, and we've got an LOS in about a minute and a half. We'd like for you to set up TV13, the SPE setup sometime before 16 hours. We think 15:30 might be a good time, and we'll see you back at 15:28.
Well, if we're getting ready to go LOS, and what I'd like for you to do is to go to data ID 747.
Okay, data ID 747.
747. And what I'd like for you to enter is a plus 000200.
Okay, 747 data select 00200.
That's correct. And enter that. That will get rid of those crystallites while we're LOS, I think. It'll be about a 4-minute LOS.
As long as you are there, I'd like to let you know there's a whole truckload full of little crystals, and there are red ones and yellow ones, and we need to increase the temperature to etch them all away.
That's an affirmative, and I think the 747's anticipated that it will do that.
Yeah, very obviously the temperature gradient was too steep or the base plate too cold because it nucleated at various places, and we have yellow ones and red ones all around the seed crystal, not etching.
We copy that. Good call. Thanks a lot.
This is Mission Control Houston. It's been a very quiet evening here in the Control Center as the third shift of flight controllers led by Flight Director Chuck Shaw continue to monitor Discovery. No systems problems have been reported by the crew during the evening. One problem which did come up earlier in the day on board, a temporary fail message from one of Discovery's small steering jets or steering thrusters was caused by that thruster becoming too cool, or actually the injector in the thruster becoming overheated. And once Discovery changed its orientation and the thruster again, temperatures began to adjust on it, it fired and has worked well ever since. Discovery continues in a gravity gradient attitude with its tail pointed toward the Earth and nose towards space, which minimizes the amount that thrusters are fired on board to provide a better environment for the microgravity experiments going on in the International Microgravity Laboratory. Also, because of Discovery's inclination, a 57-degree inclination, inclined 57 degrees to the equator, and the time of year, Discovery spends a great deal more time in the sun than is normal for shuttle flights, with less time on the night side of Earth. That remaining in the sun for that period of time requires some adjustment on keeping temperatures as moderate as possible on certain areas of the spacecraft. On board, the Red crew is halfway through their third day at work, consisting of mission specialist Dave Hilmers, Bill Reedy, and payload specialist Ulf Mirbold. Discovery is currently beginning its 27th orbit and continues to complete one orbit every 1 hour and 30 minutes at an altitude of 163 nautical miles. We'll regain communications with the spacecraft in about 1.5 minutes as it passes into range of the Western Tracking Satellite. At 1 day, 15 hours, and 26 minutes into the flight of Discovery on shuttle mission STS-42, this is Mission Control Houston.
Spacelab mission operations in Huntsville. Our next scheduled Spacelab TV event, live downlink video from the Spacelab module.
Spacelab Huntsville, we are go for voice. And Dave, I know you may be in the glove box. I'd like to tell Dave something just real quick, even if he's in the glove box. We're not feeding the male flies, but they would like to have those containers open just for a short bit to get some oxygen to those flies, opened inside the plastic bag, of course.
Vapor crystal growth experiment is scheduled for another live downlink TV event.
And fly 8, position 103 and 107.
At 12:36 a.m. Central Standard Time.
That's affirmative, thank you.
That will be coming up in just about 14 minutes.
Go ahead.
This is Spacelab mission operations in Huntsville.
This is MS2. I'm back in the lab.
set up for SPE?
That's affirmative.
Can work. Also, this is PS2. Do you have real-time video now?
That's negative, Wolf. It'll be about another 10 minutes or so before we get that. We have been given clearance to work on the... Ludwig is very pleased with your report. You did a good job on that, and he thinks that raising the offset temperature like that will get rid of those spurious crystals, so we're in good shape on that. He is willing to give the time now for the FES, and we've been given clearance to go to page NOM 47 in FO3, and I'll give you the steps we want to do on that page when you're there.
Okay, watch, I'm on page NOM 47, FO3, which is TTS.
That's confirmed. I'd like for you to go to step 14, sub-step 5, 6, and 7. What we want to do is power down, open the doors, take the connectors off, and check for bent pins. So rather than going to launch configuration, I just want you to take the connectors off and check whether there are any bent pins or not.
Okay, you want to do that right now?
We're ready whenever you can do it.
Answer from Spacelab.
Go ahead, Spacelab.
Okay, confirm that you want me to go to page NOM 45 and start at step 14, sub-steps 5, 6, and 7.
That's an affirm. We want you to do step 14, sub-step 5, 6, and 7 on NOM 47.
Okay, that's a work. Okay, data item 509 is entered. The data readout reads all balls and 1-5. Now it reads all zeros.
Okay, copy that.
As long as I'm waiting, I'd like to report on the VCGS again. I think we have at least 1 dozen little crystallites. There must have been a massive nucleation half an hour ago. And it is also clear that most of those little ones are polys. They look a little bit like strawberries. And one of the yellows has already disappeared, but there's one yellow left, and I think all the others are red ones.
Okay, we copy that. And the PI says he's pleased with the results we're getting. You're giving us a good description of the thing. We want to let it just continue etching back and getting rid of those spurious crystals. And so just leave it as is.
I have the feeling that we could accelerate the etching because the massive seed crystal, the ones Ludwig provided, doesn't show a sign of etching yet. It looks as if it's still growing.
Stand by one. Okay, Ulf, Ludwig agrees with your assessment that we could probably bump it up a little bit more in the offset. We'd like for you to go back to data ident 747 and enter. Tell me when you're there and I'll give you the entry.
Yeah, I have 747 selected.
Okay, and we'd like for you to enter a plus 000100. That'll be a 1 degree rise in the temperature.
Okay, on 747, a plus 1, well, a plus 0001.00, and the data readout shows 3.00.
That's good. Okay, we'd like for you now probably go ahead and open the doors and take those connectors off for us. These steps 6 and 7.
That's a work. Outbound Discovery.
Go ahead.
Television set up.
Was that TV
Television
13?
set up, 13 is complete.
We copy, thank you.
Outflow, this is PS2. We have all 3 connectors disconnected and we don't see any bent pins. And Bill Reedy is here, he took the look too and he doesn't see any bent pin either.
Well, if the birthday boy doesn't see a bent pin, then we're going to assume there are no bent pins and just reattach the connectors.
Okay. Okay, Roger. The connectors are connected.
Okay, and we're ready now. We'll have downlink video from VCGS in 2 more minutes at 15:43. And so get ready. We're going to go back and do the step 4 and 5 for VCGS.
Copy that.
And be advised, Ulf, that we got some downlink problems in format change, and so it's going to be a little bit of delay before we get the downlink TV, but we got it. All right.
This is Spacelab Mission Operations in Huntsville. Once again, we're receiving live downlink video, pictures from the Spacelab module on board the Shuttle Discovery of the vapor crystal growth system experiment, which the scientists who have developed that experiment are watching from here on the ground.
We have now reading for the crystal position of 312, which is the extreme 1 value. And I'm trying, or I will turn the crystal now such that you can see the number of crystallites scattered around the main seed crystal.
That experiment is being monitored on board the shuttle by payload specialist Ulf Merbold of the European Space Agency. The crystal is being turned so that its different facets can be observed. Richard Sharp and John Sandoro,
You see how far they are?
two of the engineers in that project team, are observing the crystal.
Okay, I'm done with the fly activity. There were a couple flies that got out. There weren't enough really be concerned, so I was able to, just the two or three that were in there, I was able to destroy and complete the activity. It just takes a little bit longer when you use that process.
I copy, and we understood that.
Mission specialist Dave
And for
Hilmers.
you, Ulf, yeah, we can see those crystals. You're right. That's an amazing number of them.
Spacelab for Dave, do you happen to know what container the flies got out of?
I didn't really note it. In fact, sometimes they get out and you don't know it until you see them flying around.
We copy, thank you.
Mission specialist Hilmers is working in the Biorack fly egg experiment using the glove box.
Okay, I'm starting the G-fresh now.
Copy.
Okay, that's the other extreme position on the reading of 045. And to give you some general description, it looks almost like a duck with her chickens.
Very picturesque. We got it.
If you count them, it's at least a dozen, even, I guess even more.
Do you see a particular pattern to their distribution around the seed, or are they look fairly random?
They look random. I'm now I'm looking through the window on top of the microscope to get a more general view. The amazing thing is that there are crystallites spread out over distance about twice as long as the seed crystal is. So it's a fairly large area, and I have the feeling that we should try to heat the base plate a little bit from its perimeter, from the periphery, in order to generate only one cold spot in the center of it. But it's also interesting that there is one yellow crystallite left that is next to the real seed, and outside of the yellow one there is a red one. And it's my understanding that the temperature increases if you go outward. So I really don't understand how it can happen that there is the seed which is yellow, which is red, correction, then comes a yellow crystallite and then a red one again.
Okay, that's just when it nucleated in the phase that gives the yellow yellow presentation, and it'll turn red with time. You will have a solid state transition to the red phase.
Copy that.
And Ludwig would like to know if they look like they're growing, or are they still etching?
I think they are still growing because the seed, the big seed, is very shiny and platter, facets, and also the little crystallites at least have not shrunk at all. They have not gone much bigger, but I don't think that they are etching right now.
Okay, well, what Ludwig is, he agrees with you that we need to raise that temperature some, but we want to do the offset again. So we'd like to go to 747 and increase it another 2 degrees, which would be an entry of 200. When you get there, I'll call it out for you.
Okay, on data item 747, I selected data, select 000200.
That's a good read. Go for it.
Okay, gives us a data readout of 00005.00.
Okay, well, what we'd like, that's a good copy on the temperature increase. We've got now that it's 5 degrees. What we'd like for you to do now is give us the angle where we are looking at the sea face and the angle that we're looking parallel to the sea face, and give us a call down on those, please.
Okay, and that is on the VC chest, right?
It's an affirmative, yes.
Stand by. Yeah, that's cell MS3. Completed the GPPF at 1550, and I'm doing the cells activity 4.
We copy, Dave.
Okay, Hansel, this is PS2. The readout for the angle. I'm starting with an angle that is looking head-on the A1 phase, or maybe A3, I don't know which one of the two, but one of the A's. That readout is 057.0 degrees.
That's looking at the A face, and we get 057.0 degrees.
FM.
This is Spacelab Mission Operations,
Okay,
Huntsville.
on one of the C1 faces, it is not easy to measure the angle because there's some pole or something like that blocking the view. But what I have, and that is within plus minus 5 degrees, is an angle of 151.0.
Okay, so within plus or minus 5 degrees of looking directly at a sea face, you get an angle of 151.0.
That's affirmative.
Okay, great, thanks.
Two different experiments are proceeding now in the Spacelab module, both of which use seeds, so as not to be confused. The seeds that payload specialist Mobold
3, activity 4 of cells is complete.
was discussing involve crystal
Copy,
growth
Dave.
seeds. And moments ago we received and are now receiving live downlink video.
The angle looking at the other A face, that is to say from the back, reads 233.6. That is also plus minus a few degrees.
Okay, is there an obstruction on that face too, when you're looking at that face?
What was the question?
Is there an obstruction when you're looking at that face also? Is that why it's off a few degrees?
Negative, there's no obstruction, but it's not, is not well illuminated, therefore it's a little bit uncertainty as far as the angle is concerned.
Copy that. Copy that. That's good. And I got 233.6 as a reading. Thank you.
Dr. David
Ludwig's very pleased.
Dr. David Heathcote and his team of investigators from the University of Pennsylvania, seeing intermittent video from the PHOTRAN, or Response to Light Simulations Phototrophic Transient Experiment.
For a sampling message on the DDU.
This particular experiment
Roger,
uses...
for your information, the sea on the other side, I can't really get at it, but I'm pretty close, and the reading now is 312, and I would think that I had to turn another 10-15 degrees, and then I would look perpendicularly at the other sea face. Maybe it depends whether we call it C1 or C2.
The PHOTRAN experiment and the
Okay, Ulf, very good. Thank you.
gravity threshold experiment both use seedlings. Those are the other kinds of seeds on board the shuttle.
And Huntsville, Spacelab Huntsville for Dave.
Go ahead.
Sorry about that. We just want to make sure you were going to go ahead to this G-thrush when the 10 minutes was up, and looks like if we run out of time before SLED, we're going to cancel that spores activity 3 we had added in.
Okay, I've got about 2 minutes on the MSB timer. I can get started on the spores now and then finish it when it's done, when the timer times out, or I'll just wait on the spores.
Gravitational plant physiology facility uses oak seedlings and wheat seedlings.
Okay, they said to go ahead with spores if you got a little bit of time.
Okay, about 2 minutes before time's out, I'll get started.
And the science team that developed that experiment is monitoring it. Those short flashes of video are enough for them to see that the plants are growing.
Otherwise, we go ahead with the next activity.
Of course, observing to see in which direction and at what rate the plants are growing. It's important to understand plant growth in space because we hope to be able to take plants with us on our future explorations of the planets and at long-duration missions like Space Station
what we'd
Freedom.
like for you to do, rather than going on to the next activity, is that we're running out of time on some of the chores that Dave's got, so we'd like for you to do the second part of that G-thrush, and then both of you move on to the SLED. Onto the... That'll be FO 1.5, Step 2 of Group 5. And then you go to the SLED rotor.
Okay, that is G-thrush 5. Confirm that, FO 1.5, Step 2.
That's affirm, yeah.
Huntsville MS3.
Go ahead, MS3.
Confirm that this was activity 3 of spores.
That's affirmative.
Okay, someone must have done this before. We've already gotten the samples taken on spores 4.
Okay, I copy. Stand by. Okay, we're standing by.
Let me check spores 2.
And Spacelab Huntsville would like to come inside with video, if that's okay.
Go ahead.
Okay, thank you.
Okay, Huntsville, I moved all the cubes from the MSB back to culture order right.
Okay, copy that. Thank you.
Okay, here comes the system checkout. Okay, test rotors are reading zeros and the temperature of 23.0. Or to be more accurate, left reads 00.3, right test rotor 00.3, culture rotor left 60.6 and right 63.6, temperature 22.4, rest temperature 22.5. That's still
Okay. Copy that, up thing.
Go ahead, Dave.
Okay, didn't I do activity 3 on spores earlier today?
Jana said that we did activity 2 and activity 3 slot.
I just did what was on the timeline, which was activity 3. I had never marked or I never remember a change coming up to make that activity 2.
Okay, stand by for a second, Dave. I understand. Okay, Dave, I'm sorry about the confusion. We've run out of time now. We're just going to have to wrap up spores and go to SLED. We're already in their time. I appreciate your effort, though, and I'm not sure what went wrong earlier. I had activity 2 down, but maybe we missed it.
Okay, it wasn't on the tags messages, was it this morning?
You're right, it was a call-up. It wasn't on the tags message.
Okay, anything we can do to rectify that here? Do you want to do, while I'm in the glove box, do you want me to do the activity 2, or is it too late for that?
No, it's too late for that now. We need to go on to SLED.
Okay.
And we're 15 seconds to a teacher.
And also on the VCGS.
Yeah, go ahead, off. Hope we went into Tedra's hand over there, and I didn't get your transmission right before. Could you repeat?
Okay, on the VCGS, no indications of etching.
Okay, copy that. Okay, it looks like there's a little bit of a list in the canister that's containing the crystal, and if that's true, the first evidence of etching would be on the side that's away from most of the nucleation. So we'd like for you to examine that side very closely if there's one side that seems to have more crystals than the other.
That's LMS3. I stowed the spores containers back in their original positions.
We copy.
Answer on the VCGS for Ludwig. I don't see any asymmetry in terms of number of crystallites around the seed crystal or something like that. And my statement that there is no indication of etching is based on the appearance of the real seed crystal. That one still has very sharp edges and defined facets and so on. And based on that, I reconfirm there's no etching going.
Okay, copy that. Are you seeing any indication of that there's etching on the spurious nuclei?
Even those have still sharp edges and don't show any indication of anything.
Okay, earlier we had just a plethora or a huge number of nuclei. Have the smaller ones disappeared and only the larger ones still remain?
Well, they are more or less of equal size. It's interesting that there are not that the dimensions are not very different if you compare them to each other.
Okay, copy that. Okay, while you're still there, we'd like to increase the offset 2 more degrees. That'll be the 747, etc.
That is 747, 200 for the data select.
That's confirmed.
That's complete. Data 47 is 7.00.
See that off. I'm going to have a talk with Ludwig, and I'll be back to you in just a second. And off, what we'd like to do is for you to know that when we're without video, the PI totally trusts your judgment. And when we get to a position where the etching has gone back and the spurious nuclei are gone, then we'd like for you to start reducing that temperature as you believe appropriate in 1 degree increments. We'll start marching down from that 7 degree offset that we have now when you see all of the crystallites that are gone.
Okay, and that would be data then 747 and then minus 1.00.
That's an affirm, yes.
In Spacelab Huntsville, we'd like to have video of the sled set up, if that's okay.
Go ahead.
This is Spacelab Mission Operations in Huntsville.
We've got live video now.
Receiving live downlink video from the Spacelab module aboard the Shuttle Discovery. As mission specialist Dave Hilmers prepares for the next exercise of the space physiology experiment, most especially the space adaptation syndrome portion of that experiment, otherwise known as SLED. The SLED experiment employs a mini sled furnished by the Canadian Space Agency. It's like a bench that slides along some tracks set into what amounts to the floor of the Spacelab module. Earlier today, the sled was employed during another run of this particular experiment. And for the very first time, the IMAX camera was used to photograph inside the Spacelab to take pictures of some of those space physiology experiments. The SPE, or space physiology experiments, employing the sled and other devices, are meant to test the proprioceptive system, which helps human beings determine space orientation. It helps us sled also measures changes in the otolith organs. On Earth, gravity acting on these organs provides a sense of up and down and helps a person stand upright by activating muscle reflexes throughout the body. However, in the absence of gravity, that pattern of sensations is changed, and the nervous system must learn to reinterpret this information or to ignore it completely. In a few moments, one of the crew members will be strapped inside the sled, and the other crew member will use the computers on board to cause that sled to move forward and backward so that we can simulate some movement. Special umbilical electrodes are attached to the thigh muscles of the crew member in the sled, and that data is recorded so that scientists here on the ground can post-flight learn more about what reactions the body had, both in the proprioceptive organs, that's the tendons rather, muscles, skin cells, and the inner ear organs. The crew on board the shuttle has had a very busy day today, working through a wide range of experiments. Just within the past few hours, the variety of experiments has ranged from plant growth to crystal growth to experiments like the sled, which employ the astronauts, crew members themselves, as guinea pigs, helping us learn more about how humans adapt to space. Information gained from this experiment will help doctors here on Earth diagnose inner ear infections and lesions and other conditions that we don't presently understand.
Alpha, PS2.
Yeah, go ahead, PS2.
Okay, I'm going off com to be a test subject.
Okay. Have fun.
Payload specialist Ulf Meerbold is the crew member who will ride in the sled during this run. And he's now positioning himself in the sled. Straps are required because, of course, in the microgravity environment, one can't sit like we do here on Earth. And even operating the computer, Dave Hilmers is required to use foot restraints to hold himself in place. One of the other experiments being conducted during this first International Microgravity Laboratory experiment is meant to help us learn more about using computers in space and the ergonomics of designing systems like that to make them more convenient and easier to reach and more comfortable to use. All of these activities are aimed at two basic purposes. One, to help man adapt better to long-duration spaceflight, preparation for the 30-year mission of Space Station Freedom, as well as exploration of the planets, returning to the moon to set up a moon base there, a permanent base, as well as going on to Mars and exploring the other planets. We need to know more about long-term exposure in space. And most all of these experiments as well have very definite practical applications on the ground as well. As indicated, the information from the space physiology experiments will help us learn more about how to diagnose and treat inner ear disease, infection, and problems. Material science experiments will help us build stronger and better aircraft engines and bridges, as well as grow crystals for use in medical science, in computers, and in remote detectors. At mission elapsed time of 1 day, 16 hours and 31 minutes, this is Spacelab mission operations in Huntsville.
Huntsville, we're looking for the headset to play back the output from to the V2F converter. We know it should be in over here in L4O, but we're unable to find it at the moment.
Dave, I understand you're supposed to use a personal Walkman headset.
Okay, the only one we have back here doesn't fit.
Then proceed without it.
Okay.
This is Mission Control Houston. Discovery is now into the first part of its 28th orbit of Earth, and we're about a little over 5 minutes away from losing communications with the spacecraft as it passes out of range of the Eastern Tracking Satellite. During the past orbit, it's remained very quiet in the control center and on board, with only routine housekeeping activities taking place. Among those was a wastewater dump, an activity that's done regularly during a space flight, shuttle flight, as well as an alignment of the inertial measurement units on board. On Discovery, Mission Specialist Bill Reedy has been taking care of those activities, while Mission Specialist Dave Hilmers and Payload Specialist Ulf Merbold continue their scientific work in the Spacelab module. The third shift of flight controllers has been working to put together the morning mail for the blue team on board Discovery, and we're about 3 hours and 5 minutes away from the blue team awakening for their 4th day at work in space. Again, it's remained a very quiet evening in the control center, and no systems problems have been reported throughout the night. At 1 day, 16 hours and 54 minutes into the flight of Discovery on shuttle mission STS-42, this is Mission Control Houston.
Slab Huntsville.
Go ahead.
Yeah, I just want to make sure that what the status was and that you knew, even though I didn't call up earlier, to continue to sled VS-FO3 after this. You have a GPPF tape, but you need to go into sled. VSFO3.
Okay, we'll continue on in sled FO3, and we're just about done with all.
Discovery Houston, about 2 minutes from an LOS back at 1701.
And Spacelab Huntsville want to make something clear. Please do the second subject on FO2, even if it means not doing FO3.
Okay.
And Spacelab Huntsville.
This is Spacelab Mission Operations Huntsville. We're receiving live downlink video from outside the Space Shuttle Discovery. In fact, a camera mounted in the cargo bay of the shuttle. The camera is
Spacelab Huntsville.
giving us live pictures of the Getaway Special experiments that are outside the Spacelab module, the pressurized module in which the crew are presently working on a number of experiments. These large barrels or gas canisters, gas standing for Getaway Special, are located at the aft end of the cargo bay behind the Spacelab module. Since 1982, several hundred non-professional professional experiments have gained access to space through NASA's Getaway Special program. The gas bridge that holds the canisters is capable of holding 12 canisters at a time. On STS-42, the current mission, we have gas canisters from 6 countries, from Australia, China, the Federal Republic of Germany, Japan, Sweden, and the United States. These gas canisters do not require crew intervention or action during the mission, but as the case with the crew activities, many of them concentrate on microgravity experiments. Shuttle Discovery is now in its 28th revolution of the Earth. And at mission elapsed time of 1 day, 17 hours, and 6 minutes. This is Spacelab Mission Operations in Huntsville.
Spacelab Huntsville.
This is Spacelab Mission Operations Huntsville. Our next live television event from the Shuttle Discovery will be more live downlink video of the space physiology experiment, the SLED experiment, which is proceeding. It's scheduled to begin at 2 a.m. Central Time, or mission elapsed time of 1 day, 17 hours, and 10 minutes. In fact, in about 3 minutes from now. Again, that's the next scheduled live video from the shuttle. Should be module video of the SLED experiment, part of the space physiology series of experiments. This is Spacelab Mission Operations, Huntsville.
Spacelab Huntsville. Spacelab, Huntsville. Com check on air to ground 1. 1, 2, 3, 4, 5. 5, 4, 3, 2, 1.
So this is PS2.
Well, thank goodness, Wolf, there you are. We've been trying to call you.
We have both of ComPro.
Okay, well, we've got that critical VCGS video coming down right now. Do you think you could go over and do the VCGS monitor for us now?
Yes, I can do that. You want Dave to stay in the seat?
Yes, that'll be fine.
Okay, so I'm at the VCGS. I'm sorry to tell you that the little crystals that started to grow a little while ago have increased in size.
Okay, copy that.
They are definitely still growing. They have sharp edges, shiny facets, and as I said before, they have gotten bigger. And I see a new one, very tiny little one, far away from the seed crystal now. That means the nucleation is also going on.
Okay, copy that.
This is Spacelab Mission Operations Huntsville. The decision has been made rather than to provide live downlink.
Okay, what we'd like for you to do is to raise the temperature on 747 by 3 degrees. So when you get there, I'll give you the call-up if you want.
Rather than provide live downlink from inside the module of the space physiology experiment.
3 degrees. Data readout reads now 10 degrees.
That's confirmed.
They have shifted to the vapor crystal growth experiment and are providing video to the science team here of the crystal being grown for that experiment. Much of the live downlink video received over the last several hours is concentrated on this particular experiment.
Okay, Ulf, what we'll do is we'll just skip the rotations right now, put it back where it was originally, and go on back and finish up with the speed work.
Can you see all the crap around the seed crystal?
Yeah, certainly can.
Mission Specialist Dave Hilmers is in the SPE sled going through that series of experiments now. It's a life sciences experiment. Vapor crystal growth experiment, of course, is a materials science experiment. As is often the case, quite a few experiments are proceeding simultaneously.
You can go on back and do the speed now.
Let me give you at least a perspective. Okay, I'm going back to speed.
Yeah, good job. Thanks a lot.
This is Spacelab Mission Operations Huntsville. This is Spacelab Mission Operations in Huntsville. Once again, the gravitational plant physiology facility team are receiving some video from the spacecraft of the oat and wheat seedlings that were planted before the mission and during the mission. They've had the opportunity to watch them grow. particular team is interested most especially in the influence of light on growth on Earth. Plants, even when they're laid on their side, send their roots down and their stems toward the sun. But that's not the situation in space. This particular team is trying to determine whether plants react to, in their growth direction, to light or to gravity or to both, and to differentiate between the two phenomena. It's important to understand plant growth in space because NASA and its international partners have had discussions and have made some plans about taking plants along with us in our exploration of the planets and long-term presence in space aboard Space Station Freedom. Plants provide oxygen in exchange for carbon dioxide and also, of course, provide food. Wheat seedlings and oat seedlings are being used in this particular mission because of the track record that scientists have, the understanding of these particular plants because of their use before, and also because of their rapid growth. Principal investigator for the PHOTRAN, or light experiments, part of GPPF, is Dr. David Heathcote. He's a principal investigator, and he is from the University of Pennsylvania in Philadelphia. On board the Shuttle Discovery at the present time are some 120 wheat seedlings and some 360 oat seedlings. Some were planted on the ground and began to grow, and some on the spacecraft earlier today. Payload specialist Roberta Bondar planted some more of them. This will be done at various points during the mission so scientists can compare the growth patterns. At mission elapsed time of 1 day, 17 hours and 24 minutes. This is Spacelab mission operations in Huntsville.
Huntsville, this is PS2. We are done on speed. But we may redo it during our pre-sleep.
Okay, and when you say you're done, did you do the VS also?
Say again, the DS?
FO3, did you do that also?
No, we did the FO2 so far.
Oh, okay. Okay, Ulf, Doug has said that it'll take about 25 minutes to do one subject in the dome, and so there's really no reason to start that with the limited amount of time we have.
How about if you do the dome during our pre-sleep?
We're working on replanning right now. We'll let you know when we need for you to do it. When you get a chance, Ulf, I've got a update on the BCGS input that we need for you to make. And go ahead, Dave.
Okay, I'll be there.
Yeah, Raj, we weren't very satisfied with the accuracy of that last run because Bill inadvertently came in during the session, and I guess we'd like to go ahead and make an extra run during our own time during pre-sleep or something, as long as it doesn't interfere with the activities of the other shift.
Okay, and so what you're saying is that even in the FO2 data on you felt like there was a perturbation in that because of disruption from Bill coming in, and you want to redo that part and also try to do the dome. Is that correct?
Yeah, I'm not. Bill had to come in and do a VCR change out during that time, so apparently we had a conflict in activities. Also, I think that we were not quite as accurate on our performance of the experiment as we would like, so we'd like to give another run, and we'll do that on our own time.
Okay, we'll take that into account down here and trying to do some replanning too, Dave. And thanks for telling us that.
Okay, Roger, I'm at the VCGS.
Okay, what I'd like for you to do is do an ID 731.
Seven, 3-1, dead ident.
And that should give you a display of 115.00. And so I'd like a data.
Confirmed.
I'd like a data entry of 0112.00. And that should give you a data display of 112 degrees.
Okay, on data select we have 112.00.
Okay, great. And that we're reducing the source temperature a little bit there to try to slow down on this growth.
Okay, we have a data readout of 112 for data ident 731.
That's a good copy, Bill. Thanks a lot.
And Roger, if it's okay with you guys, we'd like to just leave the equipment set up as it is, and if that will allow us to come back and make another run if you agree.
Yeah, Dave, as long as the traveling locks are set, then there's no problem with that.
Okay, they're set.
And Dave, we've got a few changes to the update we'd like you to input. Spacelab Huntsville for Dave.
Go ahead.
Okay, starting at 1745, previous to the TV09 GPPF setup, we'd like you to check containers 1 and 3 of spores to see if they've been sampled. If they have not been sampled, we need you to perform activity 2.
Okay, you want me to do that right now?
It's scheduled to be done at 1745, Dave, and then as soon as that's complete, you'll do the TV09. And there was a MICG positional switch change that was voiced up earlier, so those 3 things should be done in a row. Dave, here's a new update. You can do that spores as soon as you like. You don't need to wait till 1745.
Okay. Huntsville MS3.
Yeah, go ahead, Dave.
I can verify that spores 1 and 3 have not been sampled yet, and so I'll go ahead and do that now.
Okay, that's affirmative. We copy. Thanks.
Shuttle, this is PS2.
Go ahead, Ulf.
Okay, is Ludwig around?
I'll check. Ludwig's not here, but we got John on. He's a great crystal grower, too.
Okay, the BCGS crystal has not really grown along the cylindrical axis. M4, in other words, it is not really higher, or not much higher than before, but it grew, or the mercury iodide grew on the base plate, and it's getting more and more like a Dutch pancake. And the little crystallites connected meanwhile to the seed crystal, and it is worse than ever.
Well, Ludwig got back just in time for the bad news, but if you just repeat the last little bit about the seed crystals connecting, and start at the Dutch pancake and go from there.
And Huntsville from MS3 completed the spores activity 2 at 1751.
Copy Dave, spores. We copy Dave, spores, activity 2 complete, 1751. Thanks.
And that included the item entries on BG1.
Roger, Dave. Spacelab Huntsville for MS2. Bill, this is Huntsville. Word from the PI before you get ready to do that MWPE session. They'd like to encourage you to use new foot restraints if possible, and to take advantage of the mobility of the work surface to ensure that you're in a very comfortable neutral position. Okay, thanks a lot, Bill.
This is Spacelab Mission Operations in Huntsville. It was a conversation between our crew interface coordinator, Angie Johnston, and Bill Reedy, mission specialist on board the shuttle, about proceeding with the next run of the mental workload and performance experiment. And that's an experiment that will be conducted throughout the mission.
What we're wondering down here is if there looks like any indication at all that we have etching, or do you think it's still growing?
I took a look 2 minutes ago. I'm taking it now.
In the meantime, the growth of the vapor crystal growth experiment is being monitored very closely at this moment by the principal investigator here on the ground at the Marshall Space Flight Center, Dr. Ludwig Vandenberg, as well as by Ulf Mirbold, our payload specialist on board the Spacelab module in orbit around the Earth. Dr. Vandenberg himself was a payload specialist on an earlier Spacelab mission. They're somewhat concerned about whether the crystal is still growing, whether it's etching at this point, whether it's performing the way they expected it to.
That is true. It is still growing. In fact, the last hour there was no yellow mercury iodide crystallite, but now we have one again.
Okay, copy that. The appearance of another yellow crystallite. Where is that relative to the stuff around the base?
Mercury iodide crystals are being used in this particular experiment to confirm that we can grow larger and more perfect crystals in space, in the microgravity environment there. These particular iodide crystals have practical uses as sensitive X-ray and gamma ray detectors. They also can perform at room temperature. They don't have to be chilled by coolers like many crystals do. Therefore, they can serve as portable detectors in nuclear power plant monitoring, for natural resource prospecting, as well as in biomedical applications in the diagnosis and therapy of various diseases.
That's a good shot, Ulf. Thanks.
They're also useful in astronomical observing.
That's excellent there.
Also the original seed crystal, I think, still shows indication of growth.
Okay, and what we'd like to do is reduce that source temperature another 2 degrees, and that is the data ident 731 that we talked about before. When you get there, I'll give you more information.
I'm there, go ahead.
Okay, Ulf. The data ident should be 731. That would give you a data display of 112.00. We'd like a data entry of 010900.
And the data readout shows 00109.00.
Excellent. Thanks a lot, and we'll just have to ride with it and see what happens next.
Although mercury iodide crystals, such as the one being grown,
for Dave.
Go ahead.
Yeah, Dave, we just want to give you a heads up on spores, the difference in activity 2 and activity 3. Those are totally interchangeable, so everything's just as good as if we'd gone by the original timeline, and so everybody's just real happy down here, and thanks a lot for doing that for us.
Okay, that makes me feel a lot better.
But you'd done everything just exactly right, and so we're real pleased down here about that for you, too. Thanks a lot.
mercury iodide crystals like the one being grown here in this experiment.
Activities. We were supposed to have a GPPF tape change out at 1700, and we never did that because we just continued on with the sled. Can I pick that up now?
Yeah, you can go ahead and do it. And on the pen and ink PCAP we've got down here, that was scheduled for 18, so we're pretty close to that.
Okay, and I'll do that, and then I'll rotate MICG.
Okay, great.
As we were noting, the mercury iodide crystal has greater potential than existing detectors, but so far its performance hasn't met expectations because here on the ground it's very difficult to grow perfect crystals.
Roger. I'm getting close to the SAMS disk for one. Exchange the disk and drive 2. Are you ready for it?
Yeah, go ahead, Ulf.
Okie-doke.
We're now receiving live downlink video from the Critical Point facility experiment, another of the materials science experiments underway during this second day of the IML mission. Critical Point experiment is to help us understand better how fluids behave in a microgravity environment in space. On Earth, because of convection, we don't get the same kind of results with a critical point experiment as one gets in space. Critical point is a specific point reached by fluid when it's heated and when pressure is increased. The critical point, liquid and gas are the same. Now, this is a very sophisticated experiment with a very exact thermostat that allows the adjustment of temperature to 1/1000th of a degree.
Spacelab Huntsville, we'd like to come in with live TV in the module in about 3 minutes, if that's okay with you guys.
Okay.
Crew is just given permission for live downlink video from inside the module of the crew conducting his experiments. Much of the video that we receive is from cameras inside the experiments themselves, so we don't get as much opportunity to see the astronauts, rather the crew members, the payload specialists, mission specialists. But there are specific times that are set aside and other opportunities that present themselves to monitor their activities as well as the progress of the experiments. Very interested in monitoring those experiments are the science teams that have developed them. Over 220 scientists from around the world. Those responsible for these experiments are gathered here at the Huntsville Marshall Space Flight Center to not only watch but observe, and also on occasion when necessary to monitor those experiments and to interact with the crew. This is Spacelab Mission Operations in Huntsville. This is Spacelab Mission Operations in Huntsville. As promised, we're now receiving live downlink video from inside the Spacelab module, specifically giving the mental workload and performance experiment team here the opportunity to
we have,
monitor that
TV
experiment.
in the module of the MWPI work service this time.
Mounted on a special work table is a grid computer that the crew is using in a series of experiments. The mental workload and performance experiment examines the effect of microgravity on the ability of crew members to perform tasks requiring interaction with a computer workstation. This is in many ways an ergonomic experiment. In space, the crew members don't sit down at a computer as we would here on Earth. They have to use foot restraints. You also can't use a trackball or a mouse or even the keyboard in quite the same way that you would on Earth. Keys don't respond the same way.
Change out is complete, and I'll give you a system status if you want.
Mission Specialist Bill Reedy is the
Copy, Dave. We're ready when you are.
crew member now performing the MWPE experiment.
At 0. Temperature is 23.2. Left culture rotor and right culture rotor are both at 61.0. Temperature is 22.4, and the rest is at 22.6.
Okay, we copy that, Dave. And after the MICG switch position is moved, we need you to do a VCR4 tape change out for us.
Several aspects
Okay, I've gone from 3 to 4 on the MICG, and I'll do a VCR4 tape change out.
Okay, David, can you confirm that the TV setup for the seed planning GPPF was completed, the TV09?
That's affirmative. What you see, I think, is what was called out for seed planning.
Yeah, okay, I copy that. It looks good, Dave.
Should be good for MWPE as well.
Several aspects of the mental workload and performance experiment under examination. The natural posture of the human body is somewhat different in space than on Earth, and therefore the furnishings that are conducive to work in one gravity here on Earth are proving uncomfortable and somewhat inefficient in microgravity. For instance, on an earlier Spacelab mission, Spacelab-1, the crew members had to exert considerable effort to maintain their positions at a computer workstation that had been engineered for a person here on Earth. Bill Reedy at this present time is noticeably having to strain a bit to maintain his posture at the computer workstation. The IML-1 crew have a redesigned microgravity workstation with an adjustable surface. Position the computer on for their daily planning sessions and their record keeping. As is presently going on, cameras record the crew's range of motion and a variety of positions while at the workstations. And Mission Specialist Reedy is going through a set of predetermined exercises at the computer that have been pre-designed to test how well the ergonomics and the other the tactile response of the keys and of the other aspects of this experiment perform. Films and videotapes and reports from the crew, measurements of the location of the adjustable surface of that workstation will influence the design of workstations for future missions, and most especially for Space Station Freedom, which is being designed here at the Marshall Space Flight Center and at the Johnson Center in Houston, Texas. The results of this exercise are also expected to shed light on the most efficient design for performing specific computer tasks in space. This experiment was conducted earlier during this second day of the IML mission and is being performed again now. And it will be performed several times during the mission and after the flight as well, to determine whether the mental and physical performance of the crew members are influenced by adaptation to microgravity or by subsequent adaptation to Earth's gravity. Results from the pre-flight, flight, and post-flight exercises conducted by the payload crew and a ground control group will be compared. Again, this is the mental workload and performance experiment. It's provided by NASA. Dr. Harold Alexander from the Massachusetts Institute of Technology is the principal investigator. He and Anthony Arrett are monitoring that experiment from here in our science operations area at the Marshall Space Flight Center, taking notes and working along with the mission specialist as he performs the exercise. This experiment, as is the case with several of the life sciences experiments on board IML-1, the crew members themselves serve as the test subjects.
Hansel, this is PS2.
Yeah, go ahead, PS2.
Okay, I put a new laserdisc in drive 2 of SAMS, and right now I have a system error light.
Okay, stand by.
Presently, the Shuttle Discovery is about to pass over the continent of Africa in its 29th revolution of the Earth at mission elapsed time of 1 day, 18 hours, and 13 minutes. This is Spacelab mission operations in Huntsville.
Huntsville on this 3.
Go ahead, Dave.
Yeah, I'm in the middle of doing this tape change out on VCR4, and if I get into the tapes in overhead 4, I'm going to mess up the camera that you're looking at on Bill, so I'll just wait a little bit on that. Could I go ahead and take down that camera view for right now?
Yeah, just wait a couple minutes, Dave. We've got a view from the aft camera. Dave, we have a view from the aft camera. I'm not sure if overhead 4 is going to interfere with that view or not, but we can wait a while. So.
Oh, okay. Well, there are two cameras up. One of them is on overhead 4, just below overhead 4. So if you're not using that one, I'll go ahead and move it a little bit and then get into overhead 4.
Yeah, Roger, Dave. That'll be fine.
And also, PS2, the drive full LED remains on longer than a minute. It's still on.
Okay, copy that. Once you go to MAL MP-5, Wolf.
I'm already there.
Okay.
Spacelab Huntsville, we are LOS video at this time.
Okay, Armstrong, the malfunction procedure has worked. The drive full LED is off and the system LED is also off.
Could you give me the path in the MAL, Wolf, please?
Okay, that was MP-5.
I understand that. And did you just go straight down, or could just give me the boxes you went to, please?
Okay, I did blocks 1 and 2, and from there I went to block 6 because the full LED went off.
Okay, great. And then 6 to 9, right?
And from 6 to 9, yeah.
Great, thanks a lot. Just out of curiosity, Ulf, do you remember what the status of the full lights were when you started this change, and was the air light on when you first got to Sam's?
When I started Sam's, the drive full light was on. And besides that, only the power LED and the data LED, the two greens one were on.
Okay, and only one disc full light was on. Correct?
That's the form, only drive 2 full light.
Okay, great. Thank you.
Okay, I'm starting G thrash, F411, step 4.
Okay, copy that.
Huntsville, MS3.
Go ahead, Dave.
Okay, I'm on the TGS Mon, step 8. Just looked in the TGS test cell, and there are lots and lots of TGS crystallites yet. Ulf took a look as well, and he agrees there's quite a few more than what we'd want.
Yeah, Dave, we're working on a procedure. Robbie wants to do a little bit of troubleshooting during that time, but we're going to wait a few minutes until we get some opportunity for data to be downlinked. If you've got opportunity, if you'd hold off on TGS, stand by, Dave.
Meanwhile, I'd like to give you the system report on GPPF. The test rotors are both off. Temperature there is 23.0 degrees. The culture rotors left 60.6, right 61.0, and temperature was 23.4. Correction, 22.5.
Okay, copy that. Thank you.
And Dave, while you're standing by for that TGS procedure, if you would go to the forward camera, it should be set up for GPPF seed planting, and the PI feels it's a bit too tight. If you would move it about 5 degrees to the right, that would be away from the wall. We'd sure appreciate it.
Okay, do you have a view of that?
That's negative.
Okay, and you said it was too tight. You want me to zoom out a little bit too?
Dave, our guys on the ground say that it's zoomed out as far as it'll go. If you could just move it about 5 degrees to the right and back up on the zoom just a little bit.
Okay, you want me to have more of the table and less of the wall? Is that what you're saying?
Yeah, that's it exactly, Dave. We want to be able to see the posture of the people doing the planning.
Okay, and is that about the right amount of zoom, Huntsville?
You'll just have to use your judgment, Dave. We don't have anything here on the ground to go by.
APS for Dave.
Go ahead.
Yeah, we had Doug Watt requested that if you guys do get a chance to or decide to go ahead and run part of that FO2 again, that you make sure you use a new tape and label it very clearly that it's a repeat run.
Okay. Yeah, a couple of things, just to clarify that, and we'd really like to run that again because we'd like to verify that we did have a good signal coming out of the B to F converter, and since we didn't have the headset available, that's one thing that concerns us, and we'd like to make sure Doug gets a good run. So even if necessary, we'll go into our sleep period for that. Looking at the blue shift coming on, it doesn't look like they would have anything that would interfere with that.
Okay, down here looking at it, I overheard the planners talking. Ron's got some stuff back there. MWPE maybe has a couple of tapes to change out, and possibly an IMAX scene to be shot back in the Spacelab during that time. So it'll probably involve some coordination on that.
Okay, well, whatever it takes, we'll be willing to do it to get a good run.
Great. All the PIs really appreciate that attitude. So do I.